Hi everyone, my name is Jen Looper and I'm really happy to be here with you today, at least virtually. I'm still working from home like a lot of other folks here, but I'm with you in spirit here in Boston. And I'm very happy to present to you a project that I created, which is called PoseDance, and it's actually a TikTok trainer. What is a TikTok trainer? Well, we'll talk about exactly what that is if you haven't been paying attention to what all the cool kids are doing nowadays, dancing up a storm with their little TikTok application. Well, this is an app to make you tear up the dance floor, at least in your home office. Okay, my name is Jen Looper, and you can always find me on Twitter at Jen Looper. I'm the founder of an initiative to help people learn how to use front-end technologies called Front-End Foxes, and you can find us on Twitter at Front-End Foxes or frontendfoxes.org. I'm a cloud advocate lead at Microsoft, which means that I am here to help you make your web and mobile applications awesome. I'm particularly on the academic team, which means that I have the privilege of talking to students and teachers and learners of all stripes. Discover Microsoft technologies and just become better developers. So let's get started. Okay, what is TikTok? So if you have not been paying attention to what all those cool kids are doing, all those Gen Z kids, you might not have noticed that TikTok is this amazing mobile app that the kids are using to learn all different skills, dance moves, all kinds of other stuff. I want to talk about that. I want to talk about what PoseNet is, which is something that I use to build on top of TikTok. I want to dig a little bit deeper into exactly what PoseNet does and how it's built. I want to talk about how I went about building PoseDance, which is on top of PoseNet, which is on top of TikTok. And then I'm going to do a fun demo with you and make a fool out of myself trying to imitate one of the easier TikTok dances. Okay, let's go. So, what is TikTok? Okay, TikTok is the greatest mobile app. It is actually coming from the evolution of Musical.ly, which came out several years ago, and it was an app designed for kids to make music and sort of music videos. And TikTok evolved from that. It is, I would say, a total time waster, but actually it's relatively wholesome. I think it's very fun. It's a little bit like Vine used to be, if you remember Vine. Little short videos, I believe they can be up to a minute in length. You can tack 2 or 3 together, and it's a really cool and fun way to waste a lot of time on your mobile app. It's famous for dances, actually, and this is probably because it's coming from Musical.ly, and you can learn how to do all the cool little dance moves. A lot of music artists are actually starting to create songs for the TikTok dancers to go viral. I think that's kind of interesting how it's kind of impacting the music industry. And here's a link at the bottom. I'll share these slides later from the Rolling Stone, and it talks about how I spent a week on TikTok and all I lost was my mind. So lots of fun to be done on TikTok. What is PoseNet? Well, PoseNet is pose detection in the browser, and it's built on top of TensorFlow.js, which is really interesting, so that we can create these sort of body skeletons superimposed on top of videos. It can be used right on the web, and it's allowing you to do inference right within the browser. So it's pretty powerful and very cool, and you can think of some cool applications for this sort of technology. It can be used with a webcam, video, but that video needs to be within a canvas so that you can draw the key points and the skeletons on top. It can also be used with still pics. So you can just be, you can give it a photograph and it can figure out pretty quickly where the key points of the body are positioned on that picture. It can also display one or more people. You can set it to single pose estimation and it will just display one within a video, or multi-pose estimation. You can figure out where all the people in a crowd, for example, or people who are playing baseball, where they're positioned, how their bodies are situated. I like how it's being used for sports. I think that's really interesting. You could figure out, if you injured yourself sliding into first, why? Did your knee go a certain way? Did your ankle twist a certain way? I think it can also be used for fitness applications to get your form right for yoga poses, this kind of thing. I think that there's quite a lot of interesting applications that this could be used for, and I'd love to see what people are building. So let me know online. And PoseNet basically gives estimations of the position of 17 key body points. It will start with the ears and the eyes and the nose, and then it'll go shoulders, elbows, wrist, hip, knees, and feet. So it's looking for 17 key body points. It's your job, however, to create that skeleton on the canvas. So it's your job to create the little dots and the linkage of the skeleton. So this is something that might come as a surprise. It's not, out of the box creating the skeleton for you. You need to do that from within your web app. But that's okay. It's not that hard to do. An example output from PoseNet looks like this. So it'll give you the X and Y position and tell you which body part it's looking at. So for the left eye, it's 98, almost 99% sure that your left eye is here within the screen at 71 and 253, X and Y. Same thing for right eye, and it'll just go through and give you an array over and over again of the different positions of the body as it's watching the video. So it just gives you a nice JSON output like that, and you can do anything you like with it. Let's dig a little bit deeper. It's always cool to try these new applications and these new models out of the box, but I kind of like to look a little bit closer to what's going on under the hood. So PoseNet is actually built on top of PersonLab models, which is a project, and there's an academic paper, a research paper at the bottom of this screen that you can read, talking about how PersonLab was built. PoseNet is a new way of determining people's stances and actions in a video or photo. And previously, the algorithm was designed to be top-down, person first. So it would use basically a bounding box, and it would say, yes, that's a person. But this is a new way of looking at a body. It's coming from the bottom up. It's a parts first instead of a persons first top-down situation. It's a bottom-up, parts first, box-free, fully convolutional determination predicting relative position of the 17 key points, and that's eye to eye, shoulder to shoulder, and it's looking for that relative position. And it's kind of an interesting rethinking of looking at people within a picture. And it starts from the most confident detection, and it works up based on trained body poses. So there's a trained model underlying this, and then it's figuring out, oh, this is where the shoulders probably are, and here's a confidence according to that. Let's dig even a little bit deeper. Let's take a deeper look into PersonLab, which is really impressive technology and deserves a deeper dive. PersonLab training consists of two steps: detecting a person and estimating the poses. So first it attempts to detect key points, and then it groups those key points into person instances. So the network is trained in a supervised fashion, looking for 17 face and body parts using the COCO dataset, and COCO stands for Common Objects in Context. So first, it uses heat maps and short-range offset predictions to identify possible key points. And then it uses Huff voting to determine the most precise placement of a key point. And so from those votes, it creates Huff arrays alongside mid-range offsets between determined key points to detect human poses. And let me just make a note that it's interesting to take a look at Huff arrays and Huff voting. These are based on Huff transform algorithms, which is a feature extraction technique used in image analysis and computer vision, and it's designed to find imperfect instances of objects within a certain class of shapes by means of a voting procedure, and it was actually invented in 1959 and I believe patented in 1962, so it's been around a long time. And it's really interesting to see how these older technologies are being kind of used and revived and revised nowadays and put to very interesting use cases. Okay, so after it has done this voting procedure, it uses the detections to create likely instances of individual people, using long-range offsets to group the people into segmented instances of each person in an image. And it's also useful to note that all of these steps use convolutional neural networks. PoseNet is actually a project of Google Creative Labs, and it runs real-time pose estimation in the browser. And it abstracts away complexities of that model, of the PersonLab model, and creates a basic JSON structure that we as developers can use. And it encapsulates functionalities into this easy-to-use methods that we can just grab and use. Makes an installable NPM module that's part of TensorFlow models, and it accompanies TensorFlow.js, so it allows you to use these TensorFlow models right in your browser. And a little detail, it uses the fast, greedy decoding algorithm from the Person Lab paper. So it's directly descended from Person Lab. It's just making Person Lab available to you as web developers so that you can build something really interesting. Oh, and then here is a link to a Medium article that you can look at to talk about how they built PoseNet based on Person Lab. Okay. We know what we want to use. We know that we have the tools to build it. It's ready for us. Thank you, Google Creative Labs. They created something really fun that we can use right now within our web apps. So let's go ahead and build an app. What app do we want to build? Well, of course, we want to build something that has a lot of people in it and something that's video-based. So why don't we go ahead and try to use TikTok? So my idea was to take PoseNet and compare a dancer's movements to your own, comparing that TikTok video to your webcam output. So you have a video on one side from TikTok embedded with PoseNet running on top of it, figuring out the poses of that person, and it's comparing your poses running a different PoseNet model via the webcam, so that you can dance right alongside of the TikTok folks and then get a score according to the difference of your dancing. So what could go wrong, right? Well, before I go any further, I want to just raise this idea that perhaps this whole concept is inherently ableist. In other words, is it something that only people with standard abilities could do? Is it something that people with different abilities could not do? Are we comparing ourselves to people with different abilities? Are people with different abilities forced to compare themselves to people with other abilities? I think that you have to be a little bit aware that this is a road that we could go down with this type of skeleton building structure. I think I just asked myself, are Person Lab, PoseNet, or PoseDance, are these inherently ableist? Well, the one thing about these algorithms is it doesn't really make judgments. Now, it is being trained on an algorithm that we don't know much about, perhaps. It's something that we ought to maybe take a look at, where the pre-trained model is coming from. It's always good to know where the model is built and how it was built. But Person Lab and PoseNet really doesn't make any kind of judgment. It's just measuring the difference between this shoulder and that shoulder, this eye and that eye. If there is nothing there, if there's one eye, or if the ear is not available, then it just wouldn't show. So it's not making any kind of judgment. It's just measuring. But I think that creating an app on top of TikTok, comparing your moves via scoring to semi-pro able dancers might be considered ableist. So I wanted to make sure to make this an inclusive app. And I went through and I found dancers of all types. And it was actually really fun to just go through TikTok and figure out, all the people who are dancing. Let's get as many different types of dancers as we can and show them on our home screen, just to show that this is something that a lot of different people are doing, and to see how the algorithm would determine the differences. So I just want to keep that in mind as we go forward. Okay, we decided to build this app called PoseDance. I want to talk about several things that went into building this application. One of them is the design considerations involved. Another is the base architecture, using PoseNet, and some considerations that need to be taken into account, because these are pretty heavy models. How you handle webcams on the web. I'm sure you've had experience, when these the light pops up and you're on candid camera. Let's be a little careful with how we handle that on the web. How I built scoring and the leaderboard. The backend implementation, which is using Azure Functions and PlayFab, which is a really cool product that we have available, and it's great as a game backend. And then how I deployed the app. So lots of things to talk about. So let's get started. Okay, Design and architecture. Whenever I talk about this, I always like to go to package.json, my package.json file in my app, and just take a look at all the packages I'm using. I went with a Vue app because that's what I'm most familiar with. To style it, I used Bulma with Sass for styling because it's a nice kind of easy way to get a nice looking app up and running quickly. I needed a validate to validate my auth because I have some form fields that I need to validate. I have a registration and a login so that I can keep score. So I needed to have a validator for those. Vuex, I'm using Vuex to save user state, useful when you have any kind of registration or a login system. Axios, always helpful when you need to make calls to an API. And when you're using PoseNet, you need to also use TensorFlow. So you need to import TF.js, and you need to import the model, TensorFlow models PoseNet. So those are all the things that are, that's your recipe basically for building this kind of app. Okay, so using TikTok and the webcam, I wanted to use Bulma to give myself a nice side-by-side layout. So I want to have the TikTok MP4 here with the webcam output over here. Originally, I had wanted to take the embed straight from TikTok, and put it in the web page, but I wasn't able to do that because you need to have your video embedded on a canvas so that you can draw the skeleton on top of it. That means that on TikTok, you need to be able to export a video, and on some of the videos, you're able to do that. So I went ahead and I exported those MP4s and embedded them directly into my web app. I was a little nervous about doing that because I want to make sure that everyone gets attribution. So I created a page to start with, like a home page with all of the embeds so that you can kind of pick and you can preview and you can get all the attribution necessary according to TikTok's terms of use, according to what the artists want to have shown on their TikTok video. So we need to be able to ensure that preview is there and the attribution of the video by showing the original. And then I went ahead and exported the video for the second page so that you can show that live. Okay, so now that we have the interface kind of laid out, at least in our heads, how it's going to look, I wanted to make sure to be able to use PoseNet in a clean fashion. And the thing about PoseNet is these models are actually pretty big, and I need two of them. I need a model for the TikTok video, and I need another model to take estimations for your webcam. So you need to give your web app a little time to load these pretty heavy models. You can see there's a lot of megs coming through in your JavaScript heap when you're waiting. So almost everything in this app is done asynchronously. So I want to make sure to wait for the models to load, to wait for the webcam to load, to wait for the MP4 to load, because some of those are pretty big too. And I also wanted to create a functionality based on user requests because I did playtest this thing. My daughter wanted to make sure that she could watch the video first before she tested herself against it and got a score, because she thought that was a little shaky if she just went straight into the video. So we're going to ensure that the webcam is ready if we want it to, so we have to allow for a preview mode. And I wanted to have a little message to encourage login to save scores, not to force anyone to log in, but just to encourage people to log in to save their scores. So I needed to have a loader widget running. So when everything is all queued up and all the webcam is ready and all the videos are ready and all the models are ready, then you can press play. And it just takes, I believe it took about 7 to 10 seconds for all of these things to get going. So it's not the fastest moving application in the web, but then again, it's not like it's, I'm not monetizing this. It's just to see what can be done. But make sure that all that stuff is asynchronous. So asynchronicity is your friend with this kind of app. So here in this code snippet, I'm using my mounted lifecycle hook in my Vue app to start step 1, which is getting a reference to the TikTok video, setting up, enabling, and referencing the webcam video. And then I have to set up 2 canvases, one for TikTok and one for your webcam, to draw your key points and your skeletons on. I needed to load up the models, And you can see that this is all getting started, and handle video events. So detect poses when it's playing and calculate the score when it's done. So here I'm relying on animation frames. When the animation frame is complete, I'm going to go ahead and calculate the score. And when the video is playing, I'm going to go ahead and detect the pose in real time. That's assuming that all the models are loaded up. So there's really quite a lot going on in this component here to get your video and your webcam all queued up. Let's talk about the pose detection frame. So for each video, you need to load a model, and you need to so that it can start estimating the poses. And I decided to append each pose to an array for future scoring. So I'm grabbing all the poses, both in the video and in the webcam, and I'm just kind of keeping track of those, and then I'll sift through that array at the end whenever I calculate a score, and figure out the difference between your webcam output and the TikTok output. And then this is the moment where you need to start drawing the key points in the skeleton, and you're using the estimated location of the key point to draw a little dot on the canvas, which is the bit where you draw the image. So drawing the key points and drawing the skeleton are something that you yourself need to handle. And it's all done via the Request Animation Frame API, which is detecting video keyframes. So for each video keyframe, it uses Request Animation Frame, and it draws a pose, and draws a pose. So it's really, it's a pretty intensive processor type of app. It's kind of amazing to me when you think about all the stuff behind the scenes, what's going on, that this thing actually works. So when drawing a skeleton, you're going to go ahead and use the Canvas Drawing API. So you gather up the adjacent key points and you draw dots and lines using that Canvas API. I wasn't super familiar with the Canvas API. It's not something I do a lot, so I had to learn that. But to draw a dot, you basically are doing begin, path, arc, and fill for the dots. And then for the lines in between the dots, you're going to draw a segment. So it's begin, path, move to, and line 2, and stroke for the lines. And then with this, you can tweak the color and the line width. So this is all kind of DIY. You can have, a pink skeleton for yourself, or blue, or whatever you like, and you can make it wider or less wide. And it's kind of interesting to tweak the skeleton and see which is the most effective. It's actually a lot of fun. Let's talk about scoring. How to score something that creates a pretty big array. Even though these videos are pretty short, thank goodness, we still need to gather all the key points from the webcam and the video feed, and then compare the webcam points array to the video points array. So it's using the video points array as the standard. So that's the gold standard, and you are comparing yourself in your movements to that video. So you need to find the difference between the webcam points and the video points. And as you diverge from what's going on in the video, your score degrades to negative. So your score honestly is always going to be negative, and you want the least negative score possible. You want closest to 0. I don't know if this is, my daughter didn't like that. She thought that was kind of discouraging. Maybe we should get a point for everything you get closest to. Maybe there's a different scoring mechanism. Maybe it should be a little bit less harsh. But anyway, it gives you an idea of how close you are to the video one way or another. You want the least negative score. So, we can tweak that. But most importantly, I wanted to send these scores to some kind of backend. Luckily, we have something called PlayFab. PlayFab is what? PlayFab is a mobile platform as a system backend service, which is really great for games. And what I did is I put all of my calls to PlayFab in an API folder away from the web app, and then use Azure functions to call PlayFab. So here's an example of an Azure function, and this is sending the score over to PlayFab. So the statistic name that you're sending is called score, and you're sending the value. You're passing through a value to it. You need to send the session ID that you gather to get an authentication, and then all you have to do is pass in the game title ID and use the PlayFab API update player statistics to get a score. And Azure Functions works really well with the PlayFab SDK, and you can use Axios to call it from within your web app. So call these APIs that you're building via Azure Functions. You can call those using Axios in your web app, and you're off to the races, and it works really well. I also wanted to build a leaderboard. So again, I created an Azure function, and I used, again, the PlayFab SDK, which I imported via Node, via NPM, excuse me. And here I'm grabbing an environment variable that I wanted to keep secret. And it is stored actually in the place that I have decided to host this, which I'll tell you in a second. But I saved it as an environmental variable, view app PlayFab key. So I kept the secret key, and because you can always access a leaderboard without being logged in. So they ask for a little bit extra authentication. So I need to send them my developer secret key, and that is saved as an environment variable so that I can keep it out of GitHub and I don't have to expose it for potential hacking. So here I have I'm again passing in the title ID, and then here I'm also passing in the developer secret key. So that is something that's really helpful, and that you can just store this as an Azure function and then call it via Axios whenever you want to see a leaderboard. So that works really great. And now this is kind of the big reveal. So we've talked about all of the stuff that went into building this app, that it's a basic view app, that we used Azure Functions and PlayFab. But I also wanted to show you how I deployed it. And I deployed it using a brand new service that was just released a few days ago at Microsoft Build. And it's released on Azure Static Web Apps, which is a fantastic new way to store your static web apps, such as a ViewPress app or a View app, and it really works well. I'm speaking as a developer who's always looking for a clean way to host, an easy deployment, and a nice clean way to keep all of your pieces together. Azure Static Web Apps is your pony to ride. So I'd like to walk you through what creating an Azure Static Web App looks like. Now, I've already created several, but I just want to show you the one I created for PoseDance Prod. So I went ahead and created new static web app, and then it sends you to this screen. And what's going on here is it gives you an overview of all of the pieces that go into creating an Azure Static Web App. And most of it is basically it's being built out of GitHub Actions. So you can always take a look at your deployment history and your GitHub Actions runs. And this will take you straight to your history of actions, and it'll show you exactly what's been happening. If there's been any problems, like right here, there's a little problem. And you can always go and look at your configuration. And you have the opportunity to have several configurations. I want to show you this because this is where I'm storing my View app PlayFab secret key, which is that secret key that I need to have to show a leaderboard. So that is stored here, and that is so that the functions can pick them up from right within this area. So this lists the functions that are available in my API folder in PoseDance app, and there's the leaderboard, scoring, registration, and login. You also have the opportunity to create an environment based on PRs to your GitHub repo. There's role management if you want to invite users to have special user access into your application. And then there's locks and export template, which are just some administrative things. Most importantly, you have a URL that's given to you, and here we are. It's back to Proud Moss. So this is back to PoseDance. So this is kind of an exciting new product from Azure, and it was just released at Microsoft Build a few days ago. So take a look at creating Azure Static Web Apps in Azure. Okay, so I think what we should do at this point is to go ahead and demo this thing. Okay, let's do this. Okay, so I've loaded up PoseDance, the TikTok trainer. I am logged in. You can see that I'm logged in. I can also register if I want to register, but I am logged in. So I can also watch the leaderboard to see how we're doing. Those are most of my scores. They're not so fabulous. We have all kinds of dances here for your viewing pleasure. We have Charli D'Amelio. Let me just reload this guy so you can get he's up here. These embeds take a little while to load sometimes. You can't do anything on TikTok without watching dances by Charli D'Amelio. We have some really fun dances by Kiki. We have Addison Rae, If you want to do the toughest dance here, it's the original Renegade. That's a hard one. If you've got extra space, Tootsie Slide is a fun one, not too difficult. I'm going to do one that I'm pretty sure I can get right because I'm here in my chair recording this. So I'm going to load this up, and you can see that it's ready. It says I need to log in, so let me just make sure I'm logged in. Okay, we go back and go to this dance, get this loaded up. And okay, I think we're ready. So I'm going to back up and try to match this. Oops. Come on, let's get my score. Ah, not too bad. I'm actually in positive territory. Considering I screwed up the beginning of that, that's not too terrible. So that is your demo for PoseDance. Go ahead and take a look, try and test your own dance skills, and post your high scores.
Live.
Thank you so much, Jen. That was awesome. I've definitely learned some new dance moves. I am so ready. I'm so down with the kids. I'm ready for TikTok.
Definitely trying to stay relevant at this point.
So it's awesome because your talk sort of crosses over a little bit with the talk that we had earlier that was talking about other body pose tech. So can you talk a little bit about maybe some other types of body pose tech that are in use today?
Yeah, I don't know exactly what is being built today, but I think that this sort of technology has attracted a lot of attention, and it's relatively easy to implement. So if you can get the video to line up with skeleton nicely, then you could use it for things like training yoga poses. That proper belly dance moves that you need. All the ballerinas can get out there and dance with the famous ladies. I think there's just a ton of. I always wonder about the medical applications. If there's like helping people improve their posture somehow, or shoulders back.
Oh yeah, I need that.
I know, right? Like sit up straight, for God's sake, right? So lounge around. Yeah, we can have an ergonometric reminder, just like sit up straight. One of my friends did a "Don't Touch Your Face" app. So for forcing yourself to not get your hands near, your face. Lots of good fun things.
That is cool.
It's very needed at the moment, I guess, that type of thing. If we could all have that just baked into our computers, watching us all the time, nobody would be touching their faces. So do you think that this kind of technology would work on a mobile phone as it is today, or are we a little bit away from having the computational power to do it on mobile?
It's awfully heavy for a mobile device. I think you would need a good plugin, and you also need Canvas support on the mobile browsers. So, I'm coming from a native script background where we were always relying on plugins to use this kind of stuff. So you'd have to get a plugin for PoseNet, you'd have to get a plugin for Canvas drawing, which was always a challenge in native APIs. And then this particular app, as I built it, is relying on your webcam. So you'd have to redo that so you get the cam from your native device. So I think there's a lot of refactoring to do to make this thing work on mobile. Plus, even the layout wouldn't work that great. So, I don't know. I think let's just keep it on desktop and be happy.
Fair enough.
I love it. I love the idea of something that could make us more active, maybe in lockdown. Because I don't know about you, but I have not been very active in lockdown. So something like a yoga app or a dance app, or just something that will make me move a little bit more would be a brilliant idea. And PoseNet seems to make it just so much easier to build that kind of thing.
Yes, and it has the single detector plus the double detector, so you could kind of like have a challenge between you and your partner at home or something like that, or get your kids all together to challenge each other to dance off, impromptu. There's another piece of PoseNet, which is hand poses, so I'm working on a hand shadows app so that you can create, the bunny.
I love it.
Mixed stories. That's a lot of fun. The only trick with it is only one hand that's able to be detected right now. So if they ever get it so that we can have a really proper hand posing, then I think that we can have a lot of fun. It's, the useful apps that we all need and love.
Yeah.
Nice. So we've had maquette puppetry, and now we've got hand puppetry as well.
Yeah, for sure. Finger puppet.
So, I do like that idea. I just got thrown back to childhood of doing animal puppets on the wall for a moment.
Yeah. And I was thinking I would make it so that somehow grandparents could somehow do the hand motions and then create snapshots and cobble them together for a story to send to the grandkids, like a bedtime story or something like that. I don't know. So this is kind of a little similar to a HalfStack talk.
It is.
In NYC a little while ago.
Yeah. She did the puppets with the augmented reality puppets from last year. Yeah.
Right. Yep.
And I'm also reminded of the other spectrum of your talk goes towards Ramon's Dance Revolution talk, where he made his own DDR mat. And he's got a little 3-minute demo of that, in a couple talks. So there's so many nice relations between all the things we create. It's fun.
Yeah, I think just getting up, moving around is just a great thing to do, especially now. We're just turning around, turning into big fat potatoes. I'm just I'm not old enough to
and not just Zoom emoji potatoes, but real potatoes.
So has lockdown made much of a difference for you in the way that you're working?
Well, I was sort of half remote. I would go into the Boston office, which is a beautiful Microsoft office, twice a week to hang out with my colleagues, and I loved that. And the Xamarin team always had great lunches, so we would go pick up the leftovers because I'm not on that team, so I missed the Xamarin lunches, so I got it. But I tell you, I miss seeing my coworkers, although I've worked at home for ages. And I really feel like we're all missing social interaction a lot. And I think that it's kind of messing with a lot of us a little bit. So I'm looking forward. Some things are opening up a bit in Boston, so I think eventually we'll get back to that new normal, whatever that is.
It was one of the reasons I felt urgently needing to do HalfStack online, because I missed all my HalfStack friends, all my creative web people that I wasn't seeing, and because I wasn't going to any conferences. And this isn't quite the same, but it's about as close as we can get. But what is cool is I would never see all of you at one event. Over the course of the year, I would see you all, but not often together. So it's pretty neat.
That's true. Yeah, I do miss going to conferences. But I really think that whole thing was a bit unsustainable, traveling all over the place. I would always try to cobble 2 or 3 together, so at least I could, make the case for going so far. But still, one of the greatest moments of my life was going to Japan for ViewFest. And even though we had a typhoon and the conference was canceled, I hung out in a yukata and did other events, and it was just fabulous.
I flew to Tokyo in February for TSConf Japan, and it got canceled right before I was about to leave, but we were already on our way. So I took my son and we had fun. But again, it's hard, right? We typically have to travel a lot, and now everyone's just sitting at home watching us. And I don't know if this event would have worked quite the same way if everyone was at work, right? It's nice that we're able to do it from home, because we're all there. So
yeah, for sure.
I think it's about time to wrap up, but I just want to say thanks so much for your amazing presentation, as always, Jen, and your lovely slides and your inspiration. Thanks.
Nice to see everyone again. Everyone
Likewise.
Stay healthy, take care.
You too. Bye.
Hey, cheers.
Thanks,
Bye.
Bye.
Bye.